Hi, I'm Jason Smith with MatchPoint USA. I wanted to talk a little bit about the locking blocks for Glocks that MatchPoint produces versus the OEM locking block. So the main difference is the process that they're made and the ability to hold tolerances with the process. So the OEM product is made by a process called metal injection molding. A lot of people call it MIM. Metal injection molding is the same as a composite or a polymer molded injection molding. The major difference is that the metal injection molding has cryogenically ground steel or alloy, whatever the component, whatever the metal is that they want to mold. They're mixing that with a Delrin carrier, mostly made by DuPont, and they have just a vast variety of different metals. But the main thing is that the cavity in the mold is oversized by 20.6% typically, and then the parts are sintered. And during the sintering process, the Delrin is burnt out of the material, and there's small voids and so forth for a while until the temperature is brought up to the point where the metal starts to fuse together, molecule by molecule or particle to particle. And so some of the details about a metal injection molded part is you can see the gate here on this particular part where the actual polymer and metal blend, the MIM material, is injection molded into the part. So the gate is starting to wear out. It's pretty rough in this area. You'll also notice if you turn it over on the sides, I'm not sure if you can see that in the camera, but you have a parting line here where some of the slides are pulling out to create cross holes, or the notch in the back for the other pin. You can kind of trace around there and start identifying. There's some slides inside. I don't know if you can see that, but you can see that square on the inside. And what happens on slides is they're not returning to the same position as that mold when it was manufactured. It was probably pretty smooth, but over time those the molds tend to wear out, the tooling wears out, and you start gaining more and more variables. So one of the problems that the sintering process creates is differential shrinkage. Differential shrinkage is if I look at this feature, for example, as it moves closer to the edge where the heat gets sucked out of it, it would have a tendency to shrink more in that area. It's the last place that's hot, so that the center would cool first, and as the part shrinks and cools, it moves. So besides the tooling variables to actually produce the parts from the raw materials, the sintering process, when the part ends up shrinking and coming down in size, there's a lot of variables there. So if we were to take a micrometer and measure these legs, for example, we start out at the tip here. We have 756 thousandths and a tenth. We slide it down the legs, and toward the back, 751 thousandths and 3/10. So it doesn't seem like a big deal, but that's quite a variable of over 5 thousandths. And what happens is the slide is machined straight and parallel. So what ends up happening is these tips have more space between them to where things can move around. So when this is embedded down into a plastic cavity on the gun, you have a lot more flexibility because the gun is flexible no matter how you slice it. You can grab any one of these, and it's hard to see it on a camera, but you can see that this thing moves all over the place. So when you embed this down in here, your locking block is the primary component that keeps the area where everything rests nice and square. So if it's not square and parallel, then this flexibility of the whole gun frame, it's just going to follow the locking block that's in there that everything rests on. So when these outside rails are not parallel with each other, and when the big chamfer where your barrel hooks in is not parallel, then you start creating points where either the barrel or the slide are going to where they're going to wear, and you've got this really small wear point on it. So the being parallel and precision is pretty important, and they're just not. A lot of these you can see on the back of them. There's multiple cavities. This particular part looks like cavity number 3. This part here is cavity number 10. So the OEM, they're able to produce a massive quantity for very inexpensive and in a short period of time. Anyway, when the sintering happens, this thing shrinks 20.6%, which is a lot. This part's quite a bit larger. So it does leave voids. It's not 100% dense, and you have weaknesses as these break quite often. But they're a process that Glock pretty well has to use to keep the firearms within a reasonable price range. They can't possibly CNC machine everything they make. So we're not trying to knock their product. It's a great product. But it does leave room for improvement for aftermarkets, and we appreciate that. So back to the MatchPoint USA products. If you can imagine these bars, these are basically like an extrusion. They're hot drawn, so they don't have the really nice surface finish on the outside, and they're not quite as precision, but in this case we completely mill that away. So we end up with a part that looks like this off of the machine, the CNC machine. So then they're tumbled, deburred, heat treated, and so forth to get you the finished product, and then finally plated. So when you go measure a MatchPoint billet block, you got 748 thousandths and 2/10. Bring it down to the other end, 748 thousandths and 4.5 tenths. That's so minute, it's almost not measurable with a pretty darn good micrometer. So this mic will measure 50 millionths. So they're really precision. So that's kind of an important platform to start with when you're shooting. When you maintain absolute parallelism and you have your chamfers that are measured every time and the machine is adjusted, so if they're out of adjustment, we toss the parts in the garbage and adjust it and make it so it's accurate. So those create a lot more predictable shots for especially the longer term, where you've got a bigger surface area for the wear that will happen. Pin locations fit right in there nicely. Fully CNC machine, they're very precise. We've done a heck of a lot of R&D on these different designs. We've got a bunch of different sizes and so forth for different guns. But it's the repeatability. We've got strict quality control measures that they're measured as they come off the machines. We have statistical processing that we perform as they're being machined, so we can adjust tolerances as we go if we're building trends that are not quite to the tolerances that we're looking for. And at that point we adjust the machine until they're back on track or right down the middle of our available tolerance that we have to work with. So the quality of materials, it's very difficult to beat solid material like the wrought or the hot drawn billet. The material comes out with a grain direction in the direction that we want to machine these parts, to allow for the best strength and durability. We also have the ability to heat treat these. They're through hardened rather than a case hardening, that allows a lot of impact. We also use 17.4 stainless steel, so that we end up with very good impact resistance for over and over again, and it's also good for hot conditions. So temperature changes, things like that, they don't become brittle. We've got them at a hardness that is still a little on the malleable side, but yet hard enough to resist a lot of impacts. So you don't find these broken ever. If you do, it's going to be a metal injection molded part. So then from there we have the different coatings that are offered, or no coating, like this is just simply 17.4 stainless steel. It's tumbled, heat treated, and that's not only the least expensive process, but there's not anything that's going to wear off of it because it's the wrought material itself. So then we offer a tin coating. The tin coating has, I'd say, the overall best wear resistance. They're anywhere from 4 to 12 microns thick, which has a little bit more wear resistance, and it definitely is got a low coefficient of friction, but not quite as good as the DLC as far as friction is concerned. DLC coating, diamond light carbon, has less friction, but it's thinner. It does not have the as much wear resistance, but probably not going to be noticed as far as that is concerned. DLC is anywhere from a half a micron up to 2.5 microns thick, and of course they're black, so you can't see that through the side of the between the slide and the frame, which some people like that for that purpose. So there's some pros and cons to each one of those, but primarily we're offering a much higher quality product. It's made 100% in the United States, and one thing I wanted to point out is there are a lot of products available on eBay that or throughout the web for that matter. Right in the title it says USA blah blah blah. Well, guess what? Guess where it's made? It's made in China. So we're not promoting Chinese products at MatchPoint USA. We promote American-made products. And the other part, there's a lot of people talking about, mentioning machinists and so forth. They're still not CNC machined. So the best thing to do is pay really close attention to the photos that are provided online. Look in there for the parting lines that I mentioned, pointed out on here, the cavity numbers. A lot of times they're not going to show you those photos. They don't want you to see that it's just a MIM part. It's just absolutely substandard. So pay close attention to that. You want to get what you expect. If you want the best and you don't want it breaking when you need it the most, pay attention to it. We've come a long ways with the products for many different gun models. So it's well worth spending the little bit of extra money that it costs to pick these up. There are a lot of vendors online that carry the MatchPoint USA products, and you can pick them up from any one of those vendors. It's got to have the MatchPoint packaging. You start noticing the way they're built, how they fit, the durability, and all those. You won't find super sharp edges that you'll find on some of the overseas locking blocks, and that's kind of hard on the polymer frames. They can cut into them a little bit. You just don't want any sharp edges on anything. You want them rounded off. So the way that they're actually machined, it's important that they have all the edge breaks and the radii going around the center web. They've got the concave surfaces in there where they belong. For the barrel when it tilts, they're absolutely superior. So you can pick these up on Amazon, eBay, several other vendors out there. Just do what you can to find the name brand, the quality MatchPoint products. So look for the logo. You definitely won't be disappointed, and pretty darn sure we're going to have it in stock. And thank you for supporting USA manufacturing companies.